For the introduction, induction motor, also known as synchronous motor, are essential in industrial and commercial sector due to their efficiency, robust design, and versatility. They operate through electromagnetic induction, transferring power from the sector magnetic field to the rotor without direct electrical connection, which offer advantages across device application. This motor features a simple, brushless design with a durable sector winding and rotor, adapting reliable to various speed and workload. Efficiency is critical, influenced by factors like mechanical, electric, and core losses, which can be optimized by advanced material improvers, cooling, and various frequency drive. Understanding this motor design and operation characteristic is crucial for maximizing their performance, productivity, and energy efficiency in industrial and commercial setting while meeting sustainable goals. Okay, for the methodology, we have to do the flowchart to run this Excel perfectly. To start this, we have to fill the parameter variable required for this project in Excel. Next, compute the Thevenin voltage and impedance into the Excel, and when we do this and determine the slip between 0 and 1. Next, to prevent divide by problem, the initial slip value is set to 0.01. When we not succeed, is show the error because value is divide by 0. When we succeed, we proceed to calculate using the formula as a set with the equation and calculate using the related to the equation, and the answer is done. Next, for the workflow, first we choosing the value of each parameter. Next, do manual calculation for the value, and next modeling induction motor and operate in Excel. For fourth step is plot the graph for each characteristic. Next, and analyze each plotted graph of characteristic. And lastly, we cl- completing the newsletter and presentation of this project. That's all. Thank you.
Next, manual calculations. The table shows our selective data for main parameters. First of all, we need to find the synchronous speed. The formula of synchronous speed is 120 times wave frequency over P, which is number of poles. So 120 times with 50 over 2, and we will get the answer is 3000 per minute. Then we proceed to find W sync. So we use the previous value, which is synchronous speed 3000. So we subtract the value, and then we will get the answer of W sync is equal to 314.16 rad per second. And then next, manual calculations. The table shows our selective data for main parameters. First of all, we need to find the synchronous speed. The formula of synchronous speed is 120 times wave frequency over P, which is number of poles. So 120 times with 50 over 2, and we will get the answer is 3000 per minute. Then we proceed to find W sync. So we use the previous value, which is synchronous speed 3000. So we subtract back the value, and then we will get the answer of W sync is equal to 314.16 rad per second. And then
we can summarize that the torque speed characteristic graph uh, represent how torque varies with speed, whereas speed is on the horizontal line and torque in the vertical line. As we can see, the shape of the curve varies depending on the motor design, load conditions and applied voltage. The graph typically shows the curve where torque decreases with increasing speed. This is because of the motor speeds up and the back EMF induced in the motor winding increases, which opposes the applied voltage and reduces the effective torque output. What else we can see in this graph is it shows the plot of torque speed characteristic of the induction motor. Instead of being 0, the initial slip value is set to 0.01, and the torque induced, the value of Newton meter, is equivalent to 0 for starting torque. The value increases proportionally as the pull-out torque and it becomes pull-up torque at 55.14 Newton meter and it reaches a speed of 3095 rpm. And this is how the graph works for the torque speed.
next, result and discussion for power speed characteristic. From the left, we can see the graph of power speed characteristic. This graph shows the power speed. Result of the graph is get from the Microsoft Excel. From the graph, maximum value of output power and mechanical speed when using the selected parameters. This value increases proportionally to the maximum output power and mechanical speed at 18.15 watt and 2639 RPM. Usually, this graph displays a maximum torque, and last but not least, the power output curve often increases with speed.
In this newsletter, we can conclude that it offers a comprehensive description of the investigation of the characteristics of the induction motor. Each engine constructed with certain characteristics in mind, which is precisely modified as a three-phase induction motor with a rotor and a voltage of 400 voltage and a frequency of 60 Hz. The specs of induction engine play a vital role in this matter. The aim of this research is to examine the torque speed, the power speed. These two characteristics of induction motor is to predict how the electric motor will perform when the load changes throughout this operation. In summary, the analysis of the torque and speed power, the torque speed and power speed characteristics of a precisely modeled three-phase induction motor with a wound rotor provides important insights into the operational behavior and performance capabilities of the motor. This knowledge is crucial for developing motor technology, increasing energy efficiency, and meeting the diverse demands of modern industrial and commercial applications. Thank you.
So for appendix, the parameter value that we have choose for our group assignment or our group project is stated as below. So for parameter, we have rated voltage, that value is 400 volt, system frequency is 50 Hz, number of pole is 2, and our rated horsepower is 50. For impedance, we have 5 impedance: R1 0.6 ohm, X1 0.7 ohm, R2 0.2 ohm, X2 1.45 ohm, and Xm is 10 ohm. For power losses, we have 3 power losses. The first one is mechanical loss, 900 watt, core loss 500 watt, and for our machinist's loss percentage rate with horsepower is 0.5%. So this is the Excel work for our project for group electric machine. We have 4 tables here. First and foremost is the table for main parameter or our variable. We have rated voltage, system frequency, number of pole, and rated HP. So our rated voltage we have choose is 400 volt. Our system frequency is 50 Hz. Number of pole is 2, and our rated horsepower is 20. We have 5 impedance here: R1 0.6 ohm, X1 0.7 ohm, R2 0.2 ohm, X2 is 1.5 ohm, and Sm is 10 ohm. So we have 4 losses here: mechanical loss, core loss, machinist's loss, and machinist's loss without output. And we have our operating slip, output and input power, and our efficiency. So here is the table that consists of our value for the impedance that we have calculated. We have V R2 over S, JX2, R2 over S plus JX2, JSM, and JX1. And our impedance here, our theta, cos theta, and our line current. And this is the table for our Thevenin value. We have V Thevenin, R Thevenin, and X Thevenin value for our impedance Thevenin. And last but not least, this is the table for what we have calculated. We have slip. Slip we start with 0.99 until 0.00 with an interval of 0.01. We have speed in the Nm, num, denominator, torque, our max torque, our min torque, our power conversion, max power, and min power. So from here we will calculate it and get the graph for this, the torque versus speed characteristic and power over speed characteristic. So here we can see this is based from our speed in Nm and our torque, while here based on our power and our speed. And this is our formula that we have used in this calculation or in this Excel. And as you can see here, when we change our value or our variable here, we can see the value of our data or what we calculate is changing also, and the graph is changing like this. So that's all from our group. Thank you.